Hi everyone, welcome to GATE ECE channel. Today I will be solving some problems on Z transform. Okay, so the questions will be appearing on the screen. Please pause to write down the question. Let's do the second question. In the second question it is asked, let x of n equal to r of n minus r of n minus 1, where r of n is a unit ramp sequence. The Z transform of the x of n is, we have to find out the Z transform of x of n. So I am just going to draw this r of n. R of n is actually our ramp signal, right? When it is 0, when n is equal to 0, r of n will be equal to 0. When n is equal to 1, r of n will be equal to 1, and so on, right? N is equal to 2, r of n will be equal to 2, 3, and etc. So this is our r of n, and the next one is r of n minus 1. So it will be shifted to the right side by 1. So it will be like this. This is 1, 2, 3, 4, 5, extra, right? So this is r of n minus 1. In the question, it is r of n minus r of n minus 1. So what will be remaining will be, at 0, it will be 0 minus 0. So that is 0. And at 1, it will be 1 minus 0. It will be 1, right? So at 2, it will be 2 minus 1, again 1. And at 3, it will be 3 minus 2, right? This is 2. So it will be like this, all having amplitude is equal to 1. So this is actually a unit step signal that is shifted to the right side by 1 unit, right? So I can write x of n is equal to u of n minus 1. Now we have to find out x of z. We know that a raised to n into u of n, whose z transform is equal to z divided by z minus a with ROC z greater than a. Okay, so here it is, instead of a, it is 1, and instead of u of n, it is u of n minus 1. So applying the time shifting property of Z transform, it is when x of n is having a Z transform x of z, and x of n minus 1 will be having an Z transform of x of z into z raised to minus 1. Okay, so u of n will be having an Z transform of z divided by z minus 1. So u of n minus 1 will be having an Z transform of z divided by z minus 1 into z raised to minus 1. That is equal to 1 divided by z minus 1 with ROC equal to z greater modulus of z greater than 1. Okay, so that's the answer, option number A. Okay, now let's. So the third question, consider the signal x of n equal to b raised to n for 0 less than or equal to n less than or equal to n minus 1, and it is equal to 0 elsewhere, right? Then ROC of Z transform of x of n. So we have to find out the Z transform, and then we have to find out the ROC. For that, we'll just write our x of n first. So writing our x of n, which is equal to b raised to n for 0 less than or equal to n less than or equal to n minus 1. X of z is actually sigma n is equal to 0 to infinity x of n z raised to minus n, right? So it is equal to n is equal to 0 to infinity. Instead of x of n, we have b raised to n, and it will be from n 0 to n minus 1, b raised to n is raised to minus 1. Expanding this, we will get 1 plus b z raised to minus 1 plus b square z raised to minus 2 plus b cube z raised to minus 3 plus etc. So here our x of z is finite for z for all z except for z equal to 0. Because if z comes equal to 0, it will be divided by 0, right? B divided by 0, what is, if anything is divided by 0, it will be equal to infinity. So the sigma, the sum will go up to infinity, which will be undefined. So x of z exists is finite for all z except for z equal to 0. So the ROC will be in such a way that this modulus of z should be greater than 0. Okay. So that's it. Greater than 0 comes because it is a right-handed signal. It is already given in the question that it is from 0 to n minus 1. So it is given that it is a right-handed signal. We know that in for finding out ROC, right-handed, for right-handed signal, it will be greater than, modulus of z greater than a or anything, or for a left-handed signal, it will be z less than a. Okay, please keep this in mind. This is a shortcut. So this is a right-handed signal. So the ROC will be equal to sigma, modulus of z greater than 0. Okay. Now x of n equal to 3 raised to n with n greater than or equal to 0 and minus 2 raised to n for n less than 0. This is a transform of x of n, as we have to find out. This is a transform of x of n. Okay. So this is a right-handed signal because it is greater than 0, and this is a left-handed signal. I have said in the previous question itself that for a right-handed signal ROC will be greater than, and for a left-handed signal ROC will be less than. Okay, so this is our A. This A is our 3 here. Okay, so if I write the ROC of 3 raised to n, it will be equal to z greater than 3. Okay, and if I write the ROC of 2 raised to n, that is my 2 raised to n, then it will be less than 2 because it is a left-handed signal, because n less than 0 is in the left-hand side, right? So the total ROC is actually the intersection of z greater than 3 and z less than 2. Okay, so it's the in intersecting point. Only if there is an intersecting point between these two ROC, then only with this z transform will occur. So if it is greater than 3, say this is a circle of radius 3, then ROC is like this. Okay, and the other ROC is less than 2. So there is no intersecting point, there is no common point between these two ROC. That is, the set will be equal to null. That is, its Z transform is not defined in this area. Okay. Now let's do the next question, the fifth question. In this, the question as it is asked, the constraint on A, so that the Z transform of the signal x of n equal to, I'll write x of n equal to a raised to n u of n plus half the whole raised to n u of n minus 1, minus of u of n minus 1, that is, it is a left-handed signal. Okay. So this is a right-handed signal. So ROC will be greater than A. This is a left-handed signal. So ROC will be less than 1 by 2. Okay. So final ROC will be the common part between these two ROCs. That is Z greater than A and Z less than 1 by 2. Okay. For this, from the option, we'll have to look what is the value of Z greater than A and Z less than 1 by 2. So what should be the value of A? It should be greater than 1 by 2. Okay. Sorry, greater than 1 by 4. A should be greater than 1 by 4.